At the end of this video, I'll ask you to try using the four unary operators of relational algebra: filter, project, reduce, and group. In math, symbols like the plus sign are operators. They take input data, perform an operation, and produce output data. Relational algebra works the same way. We have operators that accept input data and produce output data. Each operator takes one or more input relations and produces exactly one output relation. As a reminder, you can think of a relation as a special kind of data table with rules that we'll be going over in much more detail later. Operators that accept exactly one input relation are unary operators, and ones that accept exactly two input relations are called binary operators. Some advanced operators can have 3 or more input relations, but we won't give them much attention in this course. There are only 4 unary operators: filter, project, reduce, and group. Filter lets you choose which rows you want to keep. An expression like score equals 1 will match these 3 rows and remove the rest. So then we can see which creatures have a level 1 aspiration to a skill. Project lets you remove non-identifying columns or calculate new columns, or both. We have one non-identifying column here, score, that we can work with. So now with project, we've removed the score column and replaced it with a negative score column, calculated based on the original score column. Project does not let you add or remove identifying columns, which are marked with underlined bars. Changing those is the purpose of the reduce operator. Reduce lets you change the identifying columns, which usually also reduces the number of rows. Have a look at aspiration. It has 2 identifying columns, CID and S-code. If we want to go from here to a relation that has only a CID column, we perform a reduce to just CID. This is a change to the identifier by removing S-code. So that's why we would use reduce and not project in this case. Now we're going to end up with some duplicate rows, 3 1s and 2 3s. One of the rules of relations is that there can never be duplicate rows. So after the phase where we removed columns, we then automatically remove duplicate rows. The result of the reduce is a shorter relation. Group lets you make multiple row aggregate calculations such as count, average, minimum, maximum, sum, standard deviation, and so on. Here we've calculated the average aspired to score. You could also calculate the aspired to score count, which is 11 because there are 11 scores here, and so on. Group has an over option that allows you to divide up a relation's rows into multiple groupings and perform the calculations within each group. Choosing the columns that determine the grouping is just like changing the identifier with reduce. You get 1 row per group. Here we've calculated the top scores grouped over CID. So we can see the top aspired score of each creature. Like before, that means we've discarded the S-code column and the result has fewer rows. Note that unlike project, group allows us to make vertical calculations. So here we were able to take 1, 3, and 1, which came from different rows, and make a single calculation based on those numbers. We found the minimum of those 3, which happened to be 1. Group is the only operator that allows you to work vertically. And those are the 4 unary operators. There are many more details to cover about these operators that we'll continue to cover in the next videos. Starting with the tiny database, let's review some of the queries that we introduced in the last video. So who floats? Or rather, who has achieved floating? In this case, let's make it really simple and just find the CID of each creature with a floating that is S-code equals A achievement. For this query, we can work with just the achievement relation because it contains all the information we need. We need to do 2 things. We need to filter down to the rows with an S-code of A, and then reduce to get just a CID column. And it's reduced because we only want CID in the result, and that's not the whole identifier we started with. In this case, reduce did not cause any rows to be lost because their CIDs were already unique. When writing operators, if you first draw the shape outline and then start writing into the shape, you'll likely run out of space. I recommend writing all the content first and then drawing the outline around it after. It'll be a lot easier. So now check your understanding. See if you can figure out which operators to use for these queries and what you should write into each operator.